share with you the mathematical practices that are part of the calculus framework, because I think these mathematical practices are something that we should all be doing from second, third, fourth grade all the way to before kids get to calculus. And I want to highlight just two of them. Right, next slide. Reasoning with definitions and theorems and building notational fluency. So these are two practices that if kids are able to have experiences that allow them to play in these domains, we think that they'll do better at calculus. And I have to tell you, the reason these practices are in the calculus framework is the concern by the university professors that the kids were coming to calculus at the university level with a lot of rote procedural understanding and very little conceptual understanding. So these practices were an attempt to bridge that, to encourage teachers to deliberately provide opportunities for kids to engage in these practices. Next one, Fred. And so my first question is, where do your students reason with definitions and theorems? That's something for you to think about. This were a longer time, I'd actually have you respond, but I want you to think about that. I want to show you a clip. So this was a sixth grade class, and the teacher had given the kids a quadrilateral. It looks kind of like a parallelogram there. And the question was, how does the area change if you slant the sides? Okay? So Troy's going to start the clip. The kids have been working and trying to figure this out. Now one little girl is up to explain.
So what is that?
The area can change. Because we slanted the edges so much that the area is smaller than how it was earlier because the angles are smaller, and so the area is being smaller. Yeah.
You're not allowed to measure the area.
I set it up so that you're not allowed to measure the area.
Yeah, like
Wait, we got a question now.
Yeah, there's a way to measure the area, we use that, and I think that if we did it on there, we would still find that it's one because
How did you measure the area?
I used the formula.
But Kaylee, sometimes it doesn't. I don't think that formula always works to find area.
That's enough, Troy. Okay. So there was something wrong with the way that little girl had been reasoning about using a formula, right? And she was sure, although I will tell you this video was made a couple of years ago, and the little girl's in high school now, and she said to her teacher, I can't believe I actually thought that when I was in sixth grade. But what a lot of kids do. Next one, right? And so as teachers, no matter where you're teaching, in the domain that you're in, I think we should be giving kids the opportunities to do these kinds of reasoning so that they understand what they're working with. Next one, Trey. So, why is the sum of an even number and an odd number odd? What do you use to go back to figure that out? Find the length of the missing side. What's missing from that? What's missing? Nicole, what's missing?
The right angle designation.
The right angle. In the problems that you do in your books, do you ever give them some that aren't automatically right angles and make them decide when it works and when it doesn't work? When in doubt, write it out. You don't need a lot of complicated exponent rules. You can use the definition. You can reason about what's going on with the sign if you remember that it's the y coordinate, and then you can figure a lot of stuff out about when it gets big and when it gets small and how it cycles around. You don't have to memorize that stuff, you can reason from the definition. Next one. Here's another one. I really like this one. It allows kids to go back to the definition and think about what's really going on here. By the way, a graphical representation helps a lot. Next one, Troy. The other one is notational fluency. So you guys, we get the notation, kids don't. We think they do because we tell them. But they don't hear what we say. And making the connection between the words that come out of our mouth and the symbols that they see on the page is really hard. Next one, try. I actually worked with the Dutch, and my Dutch colleagues would not let me use 1/4 for probably 2 or 3 weeks into a curriculum we were working with. The kids had to use the word, this was at 5th grade, the kids had to use the words 1/4 so that they deliberately built up a comprehension of what that symbol was representing. And we gradually moved them in to working with symbols. But you know, just look at that top line. You're a kid. That's pretty bewildering. And so part of our job is to help them understand that notation. In Ohio, believe it or not, in the 6th grade, their formula on their, this was a couple years ago, I haven't looked since then, so maybe they got better. Their formula on their state guided, you know, they give you all the formulas because you might not remember them. So in 6th grade, their formula was LW. In 7th grade, the formula turned to BH. The teachers didn't even know it. Now little kids don't know. What's the difference between LW and BH? Why did it turn into BH? It's a trick. Right? It's something new and different. I hate to tell you that there's probably no one in the world that actually, well, that's not true. But there's very few people in schools that are in statistics classes that can handle that definition, which you don't really need to give kids if they understand the concept. Next one. So we need to be giving kids experiences that allow them to play with the notational fluency, deliberately helping them interpret the notation. It's not enough to just give it to them. We have to provide experiences where they can connect that notation to words and concrete examples. So I think we need to find ways, not only the 2 that I highlighted, but if we're really trying to prepare our kids, not only for calculus, but for statistics or wherever they go, they have to be able to use these practices in order to move around comfortably in mathematics. So thanks.